Evening, folks. Oops. Yeah, we're good. I have not been live today because I had an appointment in the morning, and then I had to spend a whole bunch of hours doing microcode updates on our cluster, which was not very fun. And I'm pretty tired. But I figured I'd hop on just for a little bit and take a look at some stuff. So our experiments seem to have gone very well. Blinding. We already have 14,000 tracked things in Neptune. A lot of those are just the synthetic tests that are pretty quick. But you can see here, we've got breakout. Where is it? There it is. Very nice Pareto front on breakout. We've got a very nice Pareto front on Enduro. And not this one, this one. We've got a very nice Pareto front on Pong. It's pretty interesting that for all of these environments, it's kind of like a straight front, you know? You kind of wonder if there should be some curve here of sorts. But I think what's happened is it's figured out essentially the fastest parameters, and it's solving it with the fastest parameters, more or less. Yeah, 20 million. So actually that might mean that it could be possible to reduce the total num time steps. Though interestingly, it's not like finding a solution with one update epoch or anything, or more M's. So maybe not. Maybe not. We'll do more work on this, but for now I think we're just going to keep running all of these various experiments. We're going to queue up a few of these tonight and probably do a little bit of work on just improving carbs, generally improving the code. I don't know if I really want to start on that now. It's a pretty big task. I've only got about an hour. I don't think what I can do right now that would be like interesting. I kind of want to like review a PR or some code, get like an environment merge, that sort of thing. Let's see if anybody's around for that. Freaking Discord. Not that bad to update. All right, there we go. Silly that you need to manually update it like that, but whatever. I'm sure he doesn't know that this is on by default. Mm-hmm. Let's see if Bet's around for final Enduro review. would be good. I can also launch some of these new experiments. Do that. Creating a Pong Python class fails. Tests say it should be good. Let's look at what env we want to do next. There are a couple things I want to do here, actually. One, two, three. Kind of want to do like, maybe we do snake and rware. The next two. I definitely can't repro that. There's one actually, there is one thing I want to do here that I thought of. Why my overlays not work? View. It's very obnoxious. Well, I'll just go grab the Restream browser. Where is it? There we go. Welcome, YouTube folks. Now I can actually see this. Yeah, so the one thing I wanted to do here that I kind of realized. Well, I should do, hang on. I should actually test this properly. I'll show you what this is about in a second. Okay, so we got test random search. Okay, so we get some scores here. So we do do this. 5 maybe. And then we'll just average them. And then we'll just do let's try this. Doesn't seem particularly good. Oh, this is supposed to be max force. There we go. Still quite a bit of variance. We'll do it over 10. Let's try this for 20. There we go. So for YouTube folks that just joined, we're doing some additional tests on the new NeoCarbs hyperparameter sweep algorithm that seems to be doing incredibly well. We've got Burrito Front's 200 experiment curves on Pong. Very good result there. On Enduro, we have a very good result here. And also on Breakout, very good result here. So we've got lots of nice experiments. And what I'm doing here at the moment is I just want to make sure that the scale of the search ranges for these various parameters is going to be compatible with a random search. So you're going to be able to use the same parameters for carbs and for random search. And if I'm looking at this here, yeah, I believe that I've doubled these. So now the question is this actually a good thing that I doubled these? So if I do, if I just do this and I get rid of these, we're not gonna like close the file, we'll keep them around. How do we do? Way worse. Way worse. Okay. That's quite interesting. So can we actually do better with a tighter bound? Let's see. If I do 2, 5, 2, 5, 1, 2, 5, 2, 5. Let's see if this does better. I don't necessarily have any reason to expect it will, but the goal should be that we have the same set of hyperparameters, or the same set of meta parameters, I guess, because they're sweep parameters. Oh, dang, does this actually do better? Tighter bound does actually seem to do better. Interesting. Though I think it's because the initial parameters are pretty darn close to the initial parameters are actually really close to the optimal ones, the means. I don't think we're going to count that too highly for this. But what we are going to do at the very least, since I was doubling all these parameters in the other trials, what we are going to do global. So we have this global search scale. We're just going to set this to 1. And that should have the effect. Let me make sure it's actually being used. Global. So we have this search distribution in BASIC and has this global scale. And what that's going to let us do is it's going to let us use all these nice hyperparameters. And I'm going to be able to delete. Can delete this. Oops. Let me just check what the time step. This has a 0.5 on it, and then this 0.25, 0.5. 0.25, yeah. So the rest of these got doubled. The Pong one is at 0.5. I think that's actually 0.25 now, right? Yeah, that's 0.25. So hopefully I don't mess anything up here. But this should be 0.25 now. But then the rest of these 0.5, 1, 1, 1, 1, 0.5, oops. Okay, you can see these are, where is it, 0.25, 0.5. So these are all halved. Which means that I can just delete them all. Because now we've adjusted the scale. And the only thing that matters is this unique per environment total time steps parameter. And what we're going to do is we're going to clean this up that way. Okay, I got to go grab the breakout params off the server real quick. Just did brand new. Oops. Just did microcode updates on all these today, so they should be more stable, hopefully. So breakout config, and the only thing that we care about here is this parameter. So we're going to do this too. The scale goes to 0.25. We are set. We also have Enduro. Enduro should just be .5. So this is not a bad config, right? And this is pretty easy to set per environment now. So we're going to set this for our two new environments that we're going to test right now. It'll be Snake. And Snake is, these params look good for Snake. Or 200 mil time step environment. This is pretty good. This should be perfectly fine. This doesn't take num-envs. And it should. This really should take. Oh, okay. So this doesn't take num-envs. That's a bit of a problem. I kind of want to add it. It's a little tricky the way it's set up. Maybe we'll leave Snake for later. I don't have too long right now, so I'll do the environments that are easier to configure. We'll do, this has this num-envs. This is easy. you see that there are all these janky parameters around. Time steps 100 million. I think we're going to do 5e7 to start. 5e7. I guess we'll do 5e7 to start, and then this will go up to 2e8. And mean will be at, hey, welcome. I think 5e7 will be fine. So, you know, intuitively, it doesn't seem to me like it should take that long to solve. Maybe I'll do like this. Something like this, you know. I don't want to set it too low. Okay, so we'll do this. Give it all of that. We'll do trash pickup will be at 1 for the sweep. And then we'll do, I think R-ware should be cool. Yeah, this has no mounts. And then this is, I think this is 175 mil. But again, I don't believe that it should be that long. We'll set the max at 3e8. Min will be here. And then we'll set this 1e8. Actually, I think I'll set this 1e8 as well. So we'll set the means a little higher, so that this is decent. Okay, so this should give us, I think that this will probably be sufficient. I think it should be. So all we gotta do is we add in, we just commit this up. Breakout enduro, where's name? Oops, we're already here. And that's it. Full. And we will set up our runs. Which of these is going to be slower? Probably R-ware. What I missed? Pretty solid hyperparameter sweep algorithm that we're now in the testing stage of. So I'm going to set up two 200 experiment sweeps, one on a remote server, one on this local box, and we will continue testing these. I think that they both define score. I think, do they both define score? I guess we'll see in a moment. I should probably test that. Puffer hardware. And then it's a blade, not demo. So puffer picked up. Okay, so this does define score. Defines score very weirdly. Just negative episode length. Oh, I think it's yeah, it's how quickly you can solve it or whatever. That's fine. We'll deal with that. Ideally, we would like to have all the score functions for all of our environments nicely normalized and clean. Where's our vector arc? Oh, I guess I don't have that on this branch yet, do I? That's fine. Make sure that this has a score function. Does not have a score function. Okay. What does this look like? Okay, so this needs a score function for sure. I'm just gonna add one. That's very silly for them to not have that. We'll just do flow score. And score. It's fine. Okay, so we'll do log score equals trash collected minus 0.1 times episode length. We'll just do this for now. That'll give us a consistent score function. We need something like this in order to be able to run our sweeps. And I don't think that the current thing was very good. No, all these environments will continue to be tweaked over the coming months. They're not final by any means. We're really way more focused on pushing RL forward than like standardizing benchmarks or something. And currently it seems like the way to push things forward is to be more fast and flexible. That's what we're gonna do. Let's make sure that we have a score. Okay, there's still no score, so that leads me, to believe that something screwy is going on in the Python. No, they did the logs correctly. That's pretty weird. They did the logs correctly. Trash collected. Aggregate and clear. Return log. The only thing I could think about is, yeah, right here, float score. It's a very small Python thing. The intermediate layer with Python has its pros and cons. I initially liked it as like a way to like a soft landing to get people into lower level code. But I don't know. I'm kind of thinking now that it's better to just rip that band-aid right off. Oh, this thing trains so fast. Look at this. Yeah, there's no way that this thing is going to take. I think we're going to find a set of hyperparams that train this in like 30 mil or something. Which is what I have it set to, so this is fine. Okay, so here on this machine, we'll do sweep carbs. Neptune. Which will ask me for my token, which will just leak because who cares? This. Oops. We actually want a TMUX session. And then we'll do modes, sweep carbs. Puffer. And now we have 2 million steps per second worth of experiments running. And 2 machines. And if we give this just a moment, should have 2 new tags. No? I set Neptune. Did I comment Neptune? No, I have Neptune. Is it just not showing up yet? Oh, I didn't tag them. My bad. I just screwed that up. Tag neocarbs are where? And we'll tag this neocarbs crash pickup. And now this one goes in background. This one stays on my local machine in the foreground. And we go to, we group by systags. And now we have our nice new experiments. So here we have our score, we have our cost. This appears to be getting logged correctly. And this appears to be getting logged correctly. So, I mean, those seem to be 2-minute experiments or so. So this entire process should be a few hours for these two environments. And assuming that this works, then, we'll have nice baselines and we'll move on to the next ones. And we'll continue cleaning up and making sure everything has a consistent score function. We'll move on to maybe we'll do like triple triad and connect 4 just to finish up the simpler environments. We'll fix up snake, go. Tactics need some work still. And then we'll do the 2 big ones, MOBA and neural MMO3. And by then maybe we'll have a few more environments merged in. And that will be our initial set of baselines with our new algorithm. And then we will run some comparisons against vanilla carbs, I suppose, before I started messing with it. And we will see how well it does. I'm not sure yet if I want to write up a full paper on this. Like, papers are such a waste of time. Blog posts are much better. I'm at the very least going to do a blog post on this. At the very least. And workshop papers don't even really do anything for me either. I don't know. We'll see. I'm very interested to see how it does on the harder M's. Because, MOBA, to be fair, you can kind of just discover a not that complicated policy that does pretty well and not that long. Neural MMO3 will be a real test, though. That's a hard environment, very hard environment. So we'll see. We'll see how it goes. That's the main thing I wanted to do for now. To discuss the plans going forward, I'm going to do a couple things on stream for various academic labs and clients over the course of this week. I'm also going to probably carve out at least a day for myself to work on rewriting the carbs code. Maybe not. Maybe once I have the experiments, I'll clean it up. We'll see. But that is going to happen. I'm not going to leave the carbs code as is. I'm going to very much clean it up. It's still based on the original code from Imbue. They did a great job with the algorithm, but the code could use some work. We're going to clean that all up nicely. Probably ship it with Puffer, just as a bundled thing. We'll see. And what else? I'm leaving for a little trip on Friday. Not a very long trip. I'll be gone for a few days. But before then, we're gonna get a fair bit of cool stuff done, I'd say. There's some stuff to do on GPU Drive, NYU's GPU Accelerated Driving Sim. They're generally doing pretty well since I made everything nice and fast. They're running some nice hyperparameter sweeps. I might integrate this for them. We'll see. I've got a thing with Kathy Wu's lab where they've given me some feedback and I need to do a couple things for them. Maybe we'll do that tomorrow. And then I've got a couple client things to do on some stuff on exploration work and some stuff on robotic sim bindings for Puffer. So we'll look at that. I think I still have a few minutes here. I gotta go to dinner in a second, but I have a few minutes. I'm trying to think what other small things we can do right now that would be interesting. Happy to answer any questions people have if people are looking for help getting started or support or anything. Oh, did I miss? Oh, okay. Let's start Now finish your dinner once. Perfect. So maybe we'll start looking at this until dinner. Ah. Let me pull up his code real quick. I think it's, there we go. So 11 minutes ago, we'll review his code. This is a pretty cool environment. So you've probably seen me do this a couple times and have this weird icon up here. So Spencer implemented a version of a puzzle game, tower climbing puzzle game, 3D game. It's pretty cool. And take a look at what he's done here. Should I just pull this? Well, I have these experiments running now, so maybe not, but we will look at the code. Start with his config. See what he's set. Okay. He's got some rewards that have been clearly tuned. This is good. This is a good number of N's. He's got 2 full day synchronicity. You want me to look at your policy? We'll do that in a second. Mini batch looks good. Batch size looks good. Pretty high entropy coefficient, but if this is what tuning found, then sure. Yeah, lambda. Yeah, this is about what I'd expect. Learning rate's fine. I wouldn't suggest tuning these, Spencer. I'd kind of just leave these ones at default because if you let the algorithm tune these, it can do weird things. But these look like good settings that it's found. Yeah. Okay, and now you want to look at, was it Ocean Torch? Trying to do multi-level. Very good. This should not be terribly complicated of a policy. And it isn't. Perfect. So we have a 3D version of my net. Twos? Why twos? Why have you done this? 5 by 5 by 9. The whole game is 5 by 5 by 9, all the different levels? Well, I'm surprised. 5 by 5 is pretty small. What's the 9? Which direction is the 9? Is the 9 up? Okay, whatever x is that horizontal? Is that up? What is it? I'm trying to think. Can you solve the game only seeing 2 up, or do you have it centered above the player though, don't you? Is it centered above the player? Centered 1 below the player? How does that make any sense? He can only see one row up? You can literally only see 1 row up if you do that. That means you can't plan at all. Right, based on playing the game, you need to be able to see a few rows up. 1 above, okay. If it's 1 above, then you can see 3, okay. That's better. 2 by 2 comms can be kind of sketchy. Because they're not This isn't going to be centered on the player is the thing. You actually, like, when you comp this, you don't get anything centered on the player. So I would test both, because this might be sketchy. Flat size is 16 by, what is this number? Yeah, try 3 with stride 1. Just run the ablation, right? It's a quick ablation to run. This is 9 times 7 is 63 times 16 is, I don't know, roughly 1,000, a little less. Kind of big, but maybe okay. I think 3 by 3 brings this down to 1 by 1 by 5 at the end. I'm pretty sure. And then you'd be able to you'd be able to increase CNN channels to 32 as well, because it would be 32 times 7, which will be a reasonable number, or 32 times 5, which is a reasonable number. We'll see if that slows the policy down. But... Okay, you got a flat. Actually gets crazy close to beating level 2. While training on the params that just beat level 1. Okay. Let's see, so we got flat. If you write some sort of random level generation, it's going to work way better. And actually, that'll be cool because I can introduce you to all sorts of cool curriculum learning people. I know a lot of people in that space, or a few good people at least in that space. We got flat, which is 4 to 16. We got proj. Honestly, I don't even know if you need this layer. You could just concatenate the features raw here. If you're going to do this layer, though, don't use 16. 16 is not a good number for linear layers in neural nets. You kind of get away with it with conv channels because like you have more weights than just the 16. But 16 is where you start getting into things like local optima in search space. 32 is the bare minimum. I would make it like 64 or 128. Yeah, don't put 16s here. You can do it in conv channels because like a conv is actually a 3D block of weights, right? 16 by kernel by whatever, something, output or something. So like don't worry about that, but yeah, this is where you start getting into numerical problems, like in optimization space, and where you start hearing horrifying things about local optima. So I would not suggest this. You might not even need this, to be honest. You could just concatenate it straight to here. It might be a decent idea to have it, though. You could try both. Actually, a cute thing that you could do here would be if you make this, what did I say? 7 by, so this will be 5 and 32. Okay, then what you could do is 3 times 32 is 96. You could put this to 96. And then, does that work? 256, perfect. And then you don't even need the projection layer at all. And you can just put it straight into the LSTM. So you'd save the proj layer and keep this layer. Could be good. Sometimes you want a relu after this, sometimes you don't. Okay. This is a reasonable little network, though. Other than the 16, there's nothing that's like straight up bad. 2's maybe a little sketchy. Nothing straight up bad, though. Is this thing fast? 650K, not bad. And I assume you're network bound. What happened here? And trash pickup has one item. Oh, I think this isn't evaling. That's weird. This one's working. All right. So yeah, the stuff I told you would maybe increase network speed a little. I mean, would decrease network speed a little bit, so maybe not amazing. I don't know. Okay, something is very silly with this env and eval. We're gonna do a different env. We'll do one of your other M's. Does this have a score? Yeah, it does. Very nice. This does have a score. Should be nice and easy. Reward question. So I got, hold on. Let me move this so I can read. Right now, the goal isn't always the highest point, and yet I give a reward for climbing layers. Should I wait reaching the goal? I mean, I would stop giving it rewards above the goal and then add a +1 for the goal is what I would do. Just like stop giving it rewards above the goal and add a +1 for the goal. Probably the simplest thing. All right, triple triad. How the hell does it take 200 million steps for you to solve triple triad? That's kind of silly. We're gonna go like this. Yeah. We'll do, what do we do? 5e7, 1e8. Need 1e9. It can have like, I don't know, 4e8, something like this. We'll see if this is good. So I give you your total time steps param, and then we will run. Triple triad. Different hyperparameters versus yeah, solving a distribution of levels could have a different set of hyperparameters. I don't think you want to like go find a different set of hyperparameters for each individual level though. I think what you'd rather do is you'd rather have a bunch of levels, maybe PCG levels, whatever, and solve the distribution. Here's your triple triad M's. We're now using this as a benchmark. Hopefully, you can solve it. I don't know what's the best as you can technically do at this. But anyways, we got 14 points so far for Rware. None of these seem to be doing particularly amazing. It'll be interesting to see how it does over time. It's pushing the total time steps down a little too low, maybe. I mean, it's going to do that. We'll see. Can we talk about PCG for a second? Do you think a path verifier is hard? Is it just modified breadth first with legal moves? Yeah, it's a little annoying because you can change the state. So you'll probably need to have state changes. You'll probably need to have like fast state sets, which if you have the state in an array, is just a mem copy. So that could be a little bit tricky. But otherwise, yeah, it's just breadth first search over actions. Because there's no randomness, it's deterministic. You could even do A star if you want. That's just a very simple heuristic addition to breadth first search. The thing is that you don't need to do this at train time, right? You can just make a file to generate 10,000 levels, right? And you can run this thing. You can maybe compute a couple statistics over them for difficulty, right? Like you can compute the number of moves required. You can compute, yeah, the number of moves required. Actually, breadth first search is good for that. You can compute the number of moves required to solve it. And I mean, that'll give you, you can do some nice curriculum stuff with that. Like, I literally was just talking to somebody about having a maze environment in Puffer, like a basic 3D maze, 2D maze environment. And they're going to implement this. They have it in like a grid engine of theirs. And I'm probably going to do a couple things on that for them. So like this is a little bit more complicated than that, but the premise is very similar. And this would be a very nice environment for doing curriculum learning type work. I mean, it's kind of similar to any of the puzzle M's, right? Like people use Sokoban a bunch for RL. People have used, grid type maze environments. People have used like all sorts of things like that. Anything you can PCG over cleanly is pretty good. And make sure that your triple triad M is running, and then I think it's dinner time. Is it not evaling? Hey, welcome. A tanky chopper? Hey, good to see you. Whoops, let's move this out of the way. I don't know what's up with all these M's not evaling. This is kind of weird. Arcade levels get pretty hard. Curriculum could be pretty relevant. It figures out pretty complex techniques early on. Yeah, I mean, a good curriculum can really just help you auto-solve stuff. And the funny thing about that is like, just randomly presenting levels is the naivest form of curriculum. And I wouldn't be surprised if with how fast your env is, that already helps. Like that might just already be enough. Okay, this is the second environment that's stuck in an eval loop. I'm a bit confused as to why that is the case. I do try to require it to eval quite a few games, but it's been stuck for a while. Try Connect 4. Okay, you have score as well here. Does this need multiprocessing on it at all? Maybe it's the multiprocessing somehow. Well, this does need it, so we'll see. Total time steps 10 milli. 8. Oh, 1E7. Do like this for you. See about this. So with 10K levels, what is logging best practice? Just check num levels completed. Tracking. Well, you're not going to track progress individually. I mean, you can check. Yeah, you can check the total number of levels, unique levels solved. You can check like the max num moves or whatever of level solved. There are lots of metrics you can come up with to see how it's progressing. If this one gets stuck, I'm going to be very confused. It's allowed to take a little bit of time here because we require a very good eval estimate in order to. We basically require it to return a large number of evaluations so that we can make sure that we're actually getting good data back. But it seems like it's getting stuck on like some of the M's are getting stuck. Levels 1 solved in only 15. Yeah, it's great. And I bet you can go even faster than that once we do carbs on it, neocarbs. This algorithm is very, very good. If you want to help with it, figure out why these hems don't freaking work. What specs do you have on the machines? Most of the machines, they have either 13900Ks or 14900Ks. So, 24 core Intel chips, basically best Intel chip you can buy in a desktop, and 4090s in them. They're pretty nice machines. In fact, I got a little write-up about the cluster here. There's some nice posts here. Like this, where is it? No, not here. Yeah, there. This is the cluster. Yes, we were. I just spent most of today doing BIOS updates on these. And one of these boxes is dead and is getting RMA'd for bad chip. All of our new boxes will be AMD. The box that I'm currently on, the desktop I'm on right now, is a test machine that has a 16-core AMD 9950X and a 4090. And then when we actually go to buy the real cluster is going to be 40 machines with 5090s and 9950Xs. 128 gigs of RAM. That'll be very nice. We'll basically have as much compute as we'll need. Yeah, these are all getting stuck, Spencer. I have no idea why, but they're all getting stuck. very weird. They get stuck on evaluation for some reason. I don't exactly know. I can't really think of why they would. No, not visualization. We run, we do train eval, right? Eval, train is the loop, not rollout, just eval. And what we do is at the end of training, we run eval a bunch in order to collect stats. So we get a really good estimate of the score. And yeah, it's not working for some of these M's for some reason, so I'll have to do some work on that. I gotta run to dinner in a second here, but we do have a fair number of folks watching at the moment. We actually peaked at 10 a couple minutes ago, which is pretty cool to get back to that. But for folks here, I stream a lot of reinforcement learning dev, pretty much all the stuff I do on Puffer. You can learn more about the project at puffer.ai. It's all open source. You can actually play some of these environments, all of our environments really, and watch reinforcement learning agents play them. They're all listed right here. We've got docs, we've got some nice cool blog stuff on here. There's stuff for companies, but again, it's all open source. And you can check out the code if you want to help us out for free. Just start the repository, trying to grow the project. It really helps. You can join the Discord, 900 people in here, hacking on awesome RL stuff. If you're trying to get into RL, or if you're trying to get into high-perf RL, one of the best things you can do is just build a new RL environment from scratch. Go through the process of getting it into PufferLib. It's a really great way to get into the stuff. And you can also follow me on X, where I post pretty much just all reinforcement learning content. And there are a couple articles here as well that aren't on the Puffer site, in case you're interested. Some of my more out there stuff. Still, I'm learning, though I'd be no help right now. Hey, you'd be surprised. You just keep the stuff that you work on simple and you do it well, right? A fair bit of stuff you can do. I've trained a lot of people in here as well, you know, via like I do so many code reviews, right? People pretty quickly get the hang of stuff. It's kind of a good way to learn. I mean, Spencer came in without RL experience and built 1, 2, 3, was it 4 environments? 4 environments. Now he's on a 5th one. Bet did Enduro. We had 2 different people do Breakout and Pong, right? Somebody did Tactics. So somebody's working on RoboCode now. Same guy that did Breakout's working on this. So there's lots of cool stuff. I'll know one obscure fact, and then I'll not even. Yeah, that's generally what your first university course in CS is for like rounding out all the dumb basic stuff that you somehow missed. I would suggest. I mean, you don't have to wait until you get to university, right? I'd suggest this one. This is their like. This is basically the course that you would take if you went to Stanford as a freshman who has like been coding for a few years but missed some fundamentals. This is the good one to take. This is pretty much the only course I really suggest to take. Like the courses very quickly diminish in value after you take the intro stuff. But this is like, this rounds out a bunch of stuff. C++ is a terrible language, but, you know, whatever. I hate C++. I really hate C++. God, it's awful. Why? Well, it's a terribly designed language. It's just a whole bunch of stuff bolted onto C. Thanks for the policy review. I'll see how that doesn't work on either PLG, or you can onboard me to science while I run sweeps. Awesome. I really would like to have some help on the science side. You know, it would be nice for people to be doing, you know, fixing up M's for sweeps, start like getting involved in running the sweeps, getting involved. Captains doing the continuous stuff. Well, one very small thing at the moment, Bet. I'm trying these on the ablation branch, and if you check, like, I think triple triad, connect four, and what else? Oh yeah, trash was it? Trash pickup. None of them seem to run with sweeps. They seem to get stuck at eval at the end of training. Captain's almost done with it, I think. It's a pretty small update. Enduro runs. Oh yeah, Bet. I'll show you this and then I'll hop off. Here's Enduro. I think we kind of solved it. So here's the Pareto front on Enduro. So in 5 minutes, we get less than 5 minutes. We have 111,000 score or whatever. Real quick. I'm gonna go get dinner, man. It's 7. I'll be around though. I'll be around either later or all week, pretty much. So yeah, time for dinner. Yeah, I'll show you this last chart, Bet. Okay, score should not be arbitrary. That should be the metric that you can rely on. That is, all of the puffer M should have a score metric that you can rely on. But if you must know, looks good. Day's complete. Goes straight up in a line. Passing 30,000, this is 10,000 cars. Yeah, these plots are laggy. I like my dashboard better. All right, folks. Yeah, I'm hopping off for now. I might be back later. I might do a later evening stream. I don't know. It's kind of late already. I might, though. But anyways, please just star the repository. It really helps me out. And check out the Discord. We'd love to have more people contributing to the project. You don't need RL experience. You just need to be, a decent programmer and be willing to learn some stuff. That's about it. Working hard on eat healthy. I eat pretty darn healthy. I think I'm doing. I just started the blueprint supplements today. I've got I don't know, like turkey, big bowl of peas, and some rice. It's pretty basic stuff.